This is Xingming Set 2020 Prelim paper, Pure Chemistry, Paper 2, A2. Describe a chemical test to identify the presence of sulfur dioxide. So you should know that sulfur dioxide is a reducing agent. So how do you test for reducing agent? You get oxidizing agent. So you have to use acidified potassium manganate. So the test is to put a filter paper soaked with acidified potassium manganate 7 into the mouth of the test tube containing the gas. Okay, so you have to use an oxidizing agent, acidified potassium manganate 7, and the observation is if a sulfur dioxide is present, then the acidified potassium manganate would turn from purple to colorless. Let's look at A2D. Okay, emission of sulfur dioxide can be reduced by passing the waste gases through a chamber containing finely divided calcium oxide. The equation for the reaction is as such. Estimated that daily sulfur dioxide emission from a copper extraction was 22 tons. So this is 22 tons. And you have to calculate the mass of calcium oxide. So there are two approaches to this question. You can use either one of these two methods. First method, of course, is a mole ratio. Second method is the mass ratio. Okay, let's look at the mole ratio first. So mole ratio, first thing you have to calculate, you have to look at the mole ratio between calcium oxide and sulfur dioxide. Okay, which is 1:1. Then for sulfur dioxide, I have 22 tons. So these 22 tons need to be converted to the number of mole. So 22 tons basically is 1 ton is 1,000 kilograms. So it's 22 times 1,000 times 1,000. You have to change it to grams. That would give you 22,000,000 gram. So you have to find out how many mole is this. So the mole of SO2 is the mass 22,000,000 divided by the MR for SO2, which is 32 plus 16 times 2. And if you use your calculator, you'll be able to find out that the number of mole is 343750. This is the number of mole of sulfur dioxide. Now, since the mole ratio is 1:1, your calcium oxide will also be this many mole. Okay, your calcium oxide will also be 343750. Then you have to find out the mass of calcium oxide, which is 343750 times the MR for calcium oxide, which is 40 plus 16, and that would give you 1925,000 gram. Okay, so when you find the mass from the mole, it must be in grams. But the question wants kilograms, so divided by 1,000, that will give you 1925 kilogram. Okay, so this is the first method using mole ratio. Now in this question, if you use mass ratio, it's actually easier. But it's okay if you're not familiar with the mass ratio, you can just continue to use mole ratio. So the second method is mass ratio. So mass ratio will still start off with the mole ratio, okay, which is 1:1. Now, mole ratio is 1 mole to 1 mole, right? What would be the mass ratio? That means what is the mass of 1 mole of calcium oxide? The mass of 1 mole of calcium oxide is simply the number of mole, which is 1, times the MR of calcium oxide. And the MR for calcium oxide is 40 plus 16, that will be 56. The mass ratio is 56 gram. And this one will be 32 plus 32, that will be 64 grams. Okay, 64 gram, that's the mass ratio. Now, your calcium oxide, your sulfur dioxide, they are 22 tons. See, look at the unit, gram. So tons, this one must be ton as well. So this is X, which is the mass of calcium oxide. So your X would be 56 over 64 times 22. Okay, 56 over 64 times 22, and that would give you 19.25 tons. Yeah, because this is in tons, so this X must be in tons as well. And since the question wants kilogram, 1 ton is 1,000 kilogram, that will be 19,250 kilogram. Okay, so take note. For this question, mass ratio, the number of steps are fewer. Mole ratio, the steps have more steps because you need to convert tons to mole, and then after that convert mole to mass. Whereas for mass ratio directly, tons, straight away you find the mass of calcium oxide in tons, then after that convert it to kilogram. Okay, take note, for mass ratio, gram, tons. So the mass of X that you find here is in tons. So you have to convert it back to kilogram. It is not in grams, it is in tons, because this 22 is in tons. Let's look at this question, B8, part 2. B8, part 2. Calculate the energy produced by complete combustion of 1 gram of each fuel. Okay, 1 gram of each fuel. So if we look at the question, over here it says that carbon and sulfur, which serve as a fuel. So the fuels actually refer to carbon and sulfur. Now let's look at the energy produced, the energy released. See, kilojoule per mole of carbon. Now the question say 1 gram. So 1 mole of carbon, how many grams? What's the mass? Which is basically the molar mass, the MR. Okay, 1 times the MR, which is 12 grams. Now likewise for sulfur, 1 mole of sulfur is actually 32 grams. So all you need to do is this 393 divided by 12. That would give you energy produced by 1 gram of the fuel of carbon. And then for sulfur, there will be 2368 divided by 32 kilojoule. So the unit will be in kilojoule. Okay, complete combustion of 1 gram of each fuel. And use your calculations to show that the total energy released from the complete combustion of the carbon and sulfur content in 1 kilogram of black powder exceeds 10,000 kilogram. Now what is this 1 kilogram of black powder? So in the question, the question actually gives you black powder is made up of potassium nitrate, charcoal, which means it's carbon, and sulfur in the ratio of 75, 15, and 10. So which means that your carbon it's 15%, your sulfur is 10%. So you have a 1 kilogram. So what is 15% of 1 kilogram? There'll be 150 grams. And then, so this carbon will be 150 grams, and this sulfur, 10% of 1 kilogram, that would be 100 grams. Yeah, so all you need to do is, just now what you found, for carbon is 12 grams, right? So you have to find out 150 grams, how much energy is produced. And likewise for sulfur, this is per gram of sulfur. So you have to find out, for 100 grams of sulfur, how much energy is produced. Okay? So that would give you, and then you have to add up, and to show that the total energy produced is more than 10,000 kilojoule. Right, let's look at B8 part C. Describe how the color and flame brightness of the fireworks produced by mixtures 1 and 2 differ. So you have mixture 1 and you have mixture 2. So you need to look at the color and the flame brightness. So in the question, actually tells you the color of the flame depends on the cation, and the brightness of the flame depends on the anion. So this table basically tells you the different colors of the flame. So for mixture 1, you have the cation will be calcium and strontium. So let's look at it. Calcium is orange, strontium and red. So which means that the flame color will be red and orange. How about the brightness? The brightness is stated here. Carbonates and oxalates. This is actually oxalates, C2O4, 2 minus is actually oxalate. Oxalate and carbonate decreases the brightness. So that means for mixture 1, it is red and orange flame, and the brightness is lower. Okay, how about mixture 2? Mixture 2, we have barium and copper 2. Barium is green, copper 2 it's blue, so it's blue-green flame. How about for the brightness? Brightness, you have nitrate and chlorate. So nitrate and chlorate increases the brightness. So the brightness is higher for mixture 2, and the color would be green and blue. Let's look at B9 part C. In experiment 1, 100 cm³ of the colorless gas was collected at the anode. What is the gain in mass of the cathode? So 100 cm³ of the colorless gas. So what is the colorless gas? So for experiment 1, you should have already done this, which is writing down the half equation at the anode. So the colorless gas is obviously oxygen. So this is 100 cm³. And the question wants the mass, the gain in mass of the cathode, which is silver. So these two half equations are related by the number of mole of electrons. So first of all, you need to find out, in order to produce this 100 cm³ of oxygen, how many, what is the number of mole of electron needed? Then using the same number of mole of electron needed, you find out what is the gain in mass of the silver, of the cathode, of the silver produced at the cathode, or of the silver discharged at the cathode. So first step, you need to find out the mole ratio. So at the anode, your mole of oxygen. So first of all, you have to find out 100 cm³, how many mole? So 100, because one mole of oxygen, 24 dm³ of volume. So 100, 24000, and that will give you 1/240. This is the number of mole of oxygen produced at the anode. Okay, then we will also look at the mole ratio of oxygen and the electron in the half equation. Okay, the mole ratio is 1 mole is to 4 mole of electron. So in order to produce 1/240 mole of oxygen, you would need 4 times of that, this number of mole of electron, which is basically 1/60 mole of electron. And then using the same number of mole of electron at the cathode, at the anode, there will be the same number of mole of electron, because the charges flowing at any part of the circuit will always be the same. So the cathode mole ratio of silver and electron, okay, silver and electron, the mole ratio is 1 mole, 1 mole, is 1:1. So which means that if I have this much of mole of electron, I would have this much the mole of silver. And 1/60 mole of silver, I can find out the mass, which is 1/60 times the AR of silver, which is 108, and that would give me 1.80 gram of silver. That would be the gain in mass of the cathode. Let's look at B10 part E. Use the two equations in stage 1 and 2 to construct an overall equation for the conversion of ammonia to nitric acid. Okay, stage 1 and stage 2. So this is stage 2, and then your stage 1 is actually this one. This is stage 1. So all you need to do is to write the two equations together. Yeah, so I copy stage 2. I copy this stage 2 to below stage 1 so that you can see what are the chemical which you can cancel off. 4HNO3. Okay, so this is stage 1, this is stage 2. Now let's look at it. So the left and the right, if let's say the chemical formula appears on the same chemical formula appears on both left and right, you can actually cancel it off. Yeah, so for example, this one is on the left of the arrow, this one is on the right of the arrow. They are exactly the same, so you can cancel off. How about water? 6 mole of water on the right hand side of the arrow. This one is 2 mole of water on the left hand side of the arrow. So you can actually 6 minus 2, that will give you 4 mole of water. So this one will become 4 mole of water. This one will be cancelled off. How about the rest? Any same chemical formula on left and right hand side of the arrow, you can cancel off. I think no more already. Okay, these two they are on the same side. 3 mole of oxygen and 5 mole of oxygen are both on the left hand side of the arrow, so you just add them up. So basically what you get is 4 mole of NH3 plus, okay, these two add up together, 8 mole of oxygen. That would give you 4 mole of HNO3 as well as 4 mole of water. Okay, So if all the coefficient is divided by 4, that would give you NH3 plus 2O2 HNO3 plus H2O. And that would be the answer. Of course, you have to add in the state symbol as well.